So module number 6, that is vSAN resiliency and data availability. So the main importance for this module will be understanding like how my data resiliency happens in backend and how vSAN help us to, recover the data, or in case of some failure, some maintenance window, minimize your downtime just because of the inbuilt resiliency features in vSAN. Okay, the main one lesson in this module is that's primarily is vSAN resiliency and data availability. So the main thing just to identify the vSAN components state. When we say vSAN component state, how my object is further distributed into components and how components being distributed as per the available kind of policies, and analyze the vSAN response, different type of hardware failure, how we manage the hardware failure situations, what are the different stages we should factor kind of hardware failure, or maybe there's some downtime we are expecting the components will be back. Then explores vSAN response, different type of network partition, like if particular host goes out of network, what will happen. Then explain the vSAN repairs object occurring a failure, how the vSAN intelligence used to recover the components or to repair the vSAN component if any of the particular objects got failure just because of any hardware failure, or maybe the underlying component failure, kind of disk, maybe capacity drive, cache drive, or maybe some your network card, or maybe the entire host. All right. So in our previous class also we have discussed something about components. So whatever object we are writing, that is further divided into components, right? That's what we have discussed in our previous session also.
Yep.
Okay, so end of the day, whatever policy is being defined, according to that policy, my components and my witness will be placed. Okay, like in this example, we can see there is 3 hosts. Out of 3 hosts, like one of the components C1 is here, one of the components C2 is here, and this is working as an witness host. Okay, so as per the different set of policies, different scenarios of failover, it will maintain the failover. All the green, you see the green status C1, C2, W. What we are saying, all the components are in active state, active and healthy state, right? Then the next scenario where we could see my component C2 got red because of a drive failed. This is just one of the example. Drive got failed on one of the host. And the third scenario is host 3 is in maintenance mode, and my particular C1 component is kind of in warning status. Okay, so there could be different scenarios. So when we say the overall vSAN states, there is primarily 2 states happens. One is active, one is degraded component. When we say the active means my object is appropriate compliant as per its storage policy, whatever the storage policy we have defined, my components are compliant against that. Then a state is called degraded. So a degraded the degraded component state is considered as a failure state. Okay, failure means is like, for an example, if that particular component being written on particular hard disk, that hard disk is failed, which cause the status of all components on the hard disk to change to degraded. So all the components with this particular hard disk will goes in the degraded state. It's not only like the C1 component from one of the object being written, there could be another components as well. So all these components go in a degraded state. Another way we can say it's a pure failure state being considered by your vSAN cluster. The another state where we say is like that's we call as an absent state. While we say the absent state, we are assuming that that particular where is this component is hosted, that particular host will be bring back in active state. Maybe that is down, that is in maintenance mode due to XYZ reason. Maybe some hardware change, maybe some patching activities kind of that. During that part, that component will be in absent state, what we called as an absent state. The absent state of component, we assume where that component is placed, like particular hard disk or on node, we are assuming that that will be back up and online after certain time of interval. Okay, that's why that's being okay. But that's a time interval is being defined. We will be talking in next upcoming slides. So that should be back actually. So that is the second state. That's what we are talking about. vSAN component state. Second state is absent state, where we are considering like a particular host or a storage device has become temporarily inaccessible just because of that host in maintenance mode, or some hardware amendments is doing. We are adding some disk or something like that. So will become, after some time, it will become access again. Then it will reconfigure. A storage policy modification has occurred and the component are being reconfigured to meet the new policy, this reconfigure state. So when we say reconfigure state, a reconfigure state is simply like, for an example, the component being written in a policy FTT1 RAID 1. Okay. But we have changed a policy kind of FTT2, sorry, FTT1, any kind. That's a change. FTT1 RAID 5. It means that in that point of time, my component will be reconfigured again. However, there won't be any impact on accessibility of that component for the end user. So that's another state. Absent state, where we are assuming the underlying hardware is absent for some time, inaccessible for some time, and it will be back after certain time interval. That time interval is by default 60 minutes. However, we can increase that also. Reconfigure state, when we are saying storage policy being changed, and due to that my component are reconfiguring again. We good so far?
Yes, sir. So
Yes, sir.
sorry.
Yeah.
First state, sir, that is the active state where everything is working fine. All the components are connected.
Right.
Everything is green. Second state is degraded when a device failure, like a host
Correct.
in a particular host, that
Permanent
particular
hardware
device.
failure we are considering. Right.
So, sir, how? Sorry, this I'm just confused between absent and
Degrade.
degraded. So after like 60 minutes, does it goes into, or 90 minutes, whatever the time we have specified, it goes into the degraded state, or it?
No. Yeah. I'll come back on it.
Okay.
So it's an intelligence of vSAN automatically. Actually, vSAN have defined some parameters, which parameter it will consider as degraded and which parameter it will consider as absent. For an example, a host we have put intentionally into maintenance mode. Okay.
Okay.
But it will factor it as an absent state. Okay. But for an example, this cache goes failure. The host detect it's a failure, or it's a it's my HB adapter that through that my device is presented. It got failure. Host itself got failure. All these kind of failure state, it will factor as degraded state. So just allow me a few more minutes, because the next upcoming slide is answering for that. But just for your understanding, an absent is a intentionally down kind of that. The component is absent for some time. That's not a actual failure. That is an absent. Degrade is something, a realistic failure of the hardware component.
Okay, sir. Yeah.
Yeah.
Sir, like planned failure, unplanned failure.
Yeah. Another way you can say, that's a right example. When we say planned maintenance, we could say
planned maintenance.
Okay. So just for an example, if all my components are active, probably you are seeing here, I am seeing the component is absent, right? For this ESXi1, it means that something is happening in the backend. It's in maintenance mode. Component is purely degraded. Okay. disk 1, you have seen under the disk 1, the status is showing degraded. It means that where that particular component was landing, it's a failure. Maybe an entire disk failure or maybe an entire host failure. Okay. So for your information, Banu, like any absent component, it will always wait by default 60 minutes to come back. But any degraded component, it will immediately to reconfigure that component to another available hosts and another available disks. Again, as per my storage policy.
Okay, sir, in this, so when will the vSAN know that this is a degrade or this is a absent? Now, when we say absent, it is like we are putting it in maintenance mode, and or we are.
Yeah, when host will go in maintenance mode, it will automatically detect it as a absent state.
Yeah.
Okay. Here it's an okay. So if any disk got failure, there is different scenarios. I'll come. There's a slides on that as well. Okay. So from resynchronization perspective, if a component is in degraded state just because of some failure, vSAN started a resynchronization began, or you can say resynchronization begins immediately to replace the degraded component with the new component. Okay. So as per your storage policy, like this is got absent. So for an example, here we have defined FTT1 RAID 1. So to meet the compliance of FTT1 RAID 1, my bare minimum requirement is there should be 2 LD component and 1 witness. Correct? So if it will go, so it will start to resync. What it means resync? Resync means is whatever is here, it will automatically immediately start to make the mirror copy of this component. That's what is FTT1 RAID 1, right? It is applicable like the same kind of as per the storage policy, my desynchronization mechanism is applicable, right? If we say if a component is in absent state, a vSAN waits for next 60 minutes is the by default time what I say. Okay, we can increase or decrease it as well. Before it restarted the resynchronization. Okay, action initiating the resynchronization module, kind of any policy change, host or disk evacuation, okay, component rebalance. I mean, these are the different scenarios where we say the resynchronization will happen. Okay. So again, in this state, if I would say this host does not come back within 60-minute time, what it will do? It will start to build a new component. Okay. Now, if you will say, sir, what happens? Like if it come on 62 minutes, still my own, but unfortunately didn't come. That's not a problem. Again, it will consider just a new original object, the primary one. It will erase it automatically, and it will it will be going to consume just to make some another component. Finally, your cluster will be rebalance. What is rebalance means is all hosts should use the equal amount of underlying storage or should utilize that. Okay, that's an intelligence. Get my point?
Yes, sir. Understood.
Now, you can ask me one more question. Sir, this is in maintenance mode. Now, that's fine. I mean, this is in maintenance mode, but still my data is being written here. Definitely, the VMs will be keep on writing the data, right? This VM C1 or maybe the another VM who have the another component where my redundancy is maintained, kind of C2, for example, or C3. So Definitely during that, this component will be increased, and once it will be back, it will resync again with the absent component also. Because during that time, some delta changes will happen with the original data, right?
Yep.
So just to rebalance, it will again resync. So some of the time, whenever any host come out of maintenance mode, you change some disk policy, storage policy, you will see within data store some resynchronization is happening. Where you can see resynchronization, it's a part of your Skyline health. From there you can check. Okay. So faster resynchronization during, what is this word? Maintenance? Is it the maintenance? I can't see it because I have a zoom ribbon on it. It's a maintenance, right? The last word.
Uh,
Transient
transient outages, sir.
outage.
Okay. It's a faster resync. Okay. So the faster resynchronization feature address the scenario. It is better to would have a new component or update the outdated existing component. Example scenario, a host in maintenance mode, more than 60-minute time lapsed. Okay. vSAN initiate the resync to replace the missing component. And during the resync, if the host returned from the maintenance window, does not matter, because now the previous example I told you, like within 60 minutes, if my host does not come back from the maintenance mode, it will start to build a component resynchronization to the another host. So during this activity, if it will come back, that's not a problem. So what it will do, it will utilize the underlying storage for another purpose, just to rebalance the cluster. So wherever you feel my maintenance window could go beyond than 60 minutes, just to better first increase your resynchronization time. Okay, because you are short, like it may take more than 90 minutes, or maybe some firmware activity, some hardware firmware upgrade activity happening, patching activities happening. Maybe it will take 90 minutes or 180 minutes. So increase that time accordingly. So faster maintenance, we can evaluate the time need to either build a new component. Actually, there is two things. Either it will build a new component if my host doesn't come back up in a particular period, or resync the exit component. When it will do resync the existing component, definitely host come back within a time frame. Correct? Within a time frame. After evaluating time of each method, we can choose the method takes the least amount of time. It's again intelligence, like wherever, I mean, it's better to build a new component, build the new one, or better to resync the existing one. Okay, so it will decide which is the faster method. But it's only the case if my host is in maintenance mode and it's back from the maintenance window, outside from the maintenance window before the time period or within the time period what I have defined for before my data take was the resynchronization. Okay, so it is
Sir,
yeah.
I have a question, sir. Sir, what in our environment, what is happening is, like, just to understand this. So whenever we are doing a patch of a server, it it reboots it. It is not taking 60 minutes. It comes back after patching in, say, 30 minutes, 40 minutes, but not 60 minutes. But when the host comes back and we exit the host from maintenance mode, and when we check the resync tab, it still shows that there are components which needs to be resynced. So in that situation, it means that whatever data which was written during that maintenance
time,
it is resyncing that and not rebuilding the components, right? That is my understanding.
You are right.
Okay, sir. Yeah, cool.
But what vSAN is now saying, like, it's all matter which is the faster one, right? I mean, better to resync it or to rebuild the new one. So wherever the less time will taken, it will take that decision. Definitely out of 100%, 90% cases would be resync, because rebuilding a new component again take the equal amount of storage, right? It's an entire new build. It will take more time. But if somewhere as per like VMware's vSAN mathematical calculation, if you would say, yeah, without, I mean, now my delta is too much heavy as per my the original component, better to rebuild that. It's all matter on the time. But yeah, definitely I would say like resync is going to be less time instead of building the new component.
And sir, is there any like way to see like is it how to
Yeah,
see out?
that we can only monitor actually.
No, like there is, we see the resync option, right? But is the like a rebuild option also we see somewhere, sir? We can identify in through commands or something, or is it like
On high level,
only
it will say only resync. Yeah.
okay? Okay.
On the status bar, it will say only resync.
Okay.
So after an outage, vSAN automatically identify and repair the that's my repair time. Okay, repair the all non-compliant component and as per my storage policy. Okay, or the process can also be manually triggered. Manually trigger means is because again my repair time is also 60 minutes. Okay, but if you factor it, yes, this is my lost object or lost component because of that failure, then you can immediately run it. Repair your object immediately. Immediately means it will start to rebuild the missing components. Okay.
Okay. By default, sir, it happens automatically, but we can do it from
Yeah.
here also.
Yeah, correct. If you want to do an immediate trigger, we can do that as well.
Okay.
So when we say durability component further reduce the time to needed to perform the synchronization by creating a temporary component to capture the new writes. Okay. So that's what I was trying to say. Like during the time of my host goes in maintenance window, whatever data will return originally is here, but whatever mirror will go, it will create a delta of it. Okay, like for example, this VM is writing the data. Once this host got the maintenance mode, this VM writing the data kind of 5 GB. So 5 GB would be delta, right? This delta will be written on here. And once it will be back, what was the original data plus this 5 GB delta, 5 GB delta will be resync, right? To this component. And finally, it will show in a active and green state. Correct? But is it possible in case of degrade? Answer is no. Correct? So just say like the phase, my vSAN will detect the degrade state. It will not create any data. It will immediate like again. It will just create the entire component. It will start to build the entire component.
So, sir, the extra 5 GB which is there, that will get created on a separate host, and then when our actual host comes back, that 5 GB will be resynced with the
redundant component, I would say.
Redundant component. So it's not like the how to say. So the new 5 GB will not go to. It will not be resynced from the active copies. It will be resynced from a delta copy.
Correct. You are absolutely. देखो डेल्टा तो यहाँ भी डेफिनेटली बनेगा, लाइक
हाँ जी
5 GB जाएगा तो 5 GB इक्वली कॉपी होगा ना, 5 यहाँ पर, बट जो
यस सर
नया बनेगा फॉर एब्सेंट कंपोनेंट C2 इट विल बी हियर, देन इट विल बी सिंक.
ओके ओके
Yeah.
Sir, if delta write is more than the original disk capacity, it will take that extra data.
Original capacity you means is original disk size.
Yes.
नहीं देखो, what happens normally, each component have its own size. Like my component cannot go beyond that 256 GB. Okay, this is my default component size. But yeah, that's a good ask. If my delta write happen more than the actual, no, see, this is the component. What I'm saying, this is the component, right? And somewhere my VMDK, right? This is my VMDK. Whatever data I am writing it here, that is further storing in the form of component, correct? And this component size is 256 GB, one component size. Okay. If any component need, like if my for particular component if going, it will create the another one, another 256 GB chunk. So if you are saying it's going beyond 256 GB, then it will create the another component for it. However, delta could be more than 256 GB, but ideally it is not being seen like whilst in maintenance mode during that time, delta could ideally it should not be more than that. I've not seen any situation so far. But in exception cases, yeah, it could be a possible scenario. That point of time, you have to increase your disk size, or your resync will be in the resyncing phase. For example, your disk the original VM disk have only 10 GB. Okay, but yeah, see that's being observed on VM level, right? Try to understand it. You cannot go beyond the original disk size. Otherwise, you will get a warning or alert on your VM itself. Get my point?
Sir, got it.
Because whatever is coming here, first you will writing your VM, and if your VM is lacking of disk, then it will show a warning to here itself, and you have to increase, right? These are the end of the day component. These are not a kind of disk. Okay. If you will increase it accordingly, maybe the next component will be created. Maybe the mirror copy will be placed on here on another host. Correct? So it should not be a challenge at all. So this is the hardware failure. One of these conditions are factored as an hardware failure. My cache drive is failure. So I can't say that is a absent, that is a degraded state. Capacity device, one of the capacity device failure. It is a degraded state. Controller, motherboard, host, degraded state. NIC failure, entire host. Network failure, or maybe the isolation, degraded state.
okay sir
Yeah. So let's see one by one. What will happen if my cache disk failure? Now you could say, sir, my capacity is okay. I mean, it still I should do, but no, this is the gateway. This is the gateway that you are data reading or writing. At that point of time, that entire disk group will be considered as failure disk group at all. So anyway, that's a all flash or that is hybrid, that does not matter. When cache drive failure, all the new writes or read will be lost. As a result, your disk group is failed. To remediate, install a new cache drive. Read it carefully. Install a new cache drive and build a new disk group. You cannot leverage in as is format. Somewhere you have to clean these disk and just onboard these set of disk again as a new disk group in your vSAN cluster. Now you would ask, sir, what will happen? The components was stored here during that time. Again, as per my storage policies, all these component will be rebuilt somewhere else. Maybe some of them could be on the same host in another disk group, or maybe some of them could be on another host in different disk groups. Right? So bring back to failure cache doesn't mean that you will again resync that, because it's factored as a degraded state. Again, a capacity disk fail, but just failure of one capacity disk, that's again a degraded. Why I'm saying it's not an entire failure, but it's a capacity only. So whatever components were hosted here, maybe they will rebuild on another SSD drive, or maybe they will rebuild to another host remotely on another SSD drive. Okay, so just because of capacity drive, my disk group never got down. It will be in okay state. Only what you have to do is everything will be running. It's a often case disk failure, especially in vSAN ready node. Okay, so what we have to do is, like, component distance physical disk are missing. vSAN uses the storage policy to rebuild the missing data to elsewhere. Correct? It's rebuilt to remediate. Delete the failed disk. I mean, delete means is we have to just from the host, we have to remove the failed disk, install a new capacity plug and play device, and add a new capacity drive into disk group. So this, however, this activity could be done in running state of the host itself. That's not a problem at all. If my disk is hot swappable, I don't need to bring that host into kind of maintenance mode or maybe the shutdown. So it's pretty straightforward. I'll go my vSAN cluster disk configuration. Earlier, you remember from where we have configured the disk group, correct? Disk configuration. From that, I'll see missing disk. I'll delete that disk and I will introduce the new disk and I will add that disk into the disk group. Okay. And what happens? The new data will be like, if this faulty disk, I bring up the new disk. Again, it's the intelligence of vSAN. It will again start to resync some of the data in new disk, because end of the day, it need to rebalance your entire vSAN cluster. Got it?
Yes, sir.
So in case of cache failure, means my entire disk group consider as failure. If I bring the new cache, I have to recreate the entire disk group again. Okay. But if my pass only capacity failure, definitely that would be a stage like where my particular disk is not available. I have to delete that from the disk group, bring up new disk, and just add into the existing disk group. Entire host failure, so you understand it better. I can't do anything in that case, right? So whatever the available disk group during that time, maybe one or maybe two different type of disk group, nothing will be happen. Automatically my rebuild will start, right? Or rebuild, I mean, for which component rebuild will happen? Depend upon my policy, correct? If some of the policy I have configured as FTT 0, RAID 0, will rebuild happen for those? Answer is no, because we have already taken a single point of failure. We didn't got it. Or in this case, will rebuild will happen? Absolutely yes. Okay. But even in FTT 1 or RAID 1, can I tolerate two node failure? Answer is no. Because I didn't configure my cluster storage policies that they can maintain the two failure at a time. Right? So any kind of rebuild, it's depend on the storage policy and also the available resources on the vSAN cluster, right? Got it?
Yes, sir.
Okay. So what is the network partition? When a network partition occurs, component can become absent for the time. When we say the partition, it's simply like one of the host lost the uh, default network connectivity or maybe the vSAN network connectivity during that time. That host is not coordinating over the vSAN network. We have to create a separate vSAN VM kernel, right? And if this host is not reachable on vSAN VM kernel, vSAN consider as it absent for the time until unless it will not start to communicate over the vSAN network, right? So if it be back, if it will back under the time, again voice 60 minutes, so it will again become the active. But till that time, again, my data will be written on the VMs, will be written as a delta copy. It will back and it will start the resync. It normally happens, you remember, right?
Sir, 1 second, sir.
Yeah.
Sorry, sir, I got joined a bit late. Okay. So in the previous situation, when we keep in maintenance mode, also same thing will happen, sir. Absent component.
Absolutely. Right. That's what we're discussing in between.
Okay, sir.
So now it's host, like there is some example how my host will get experience if any network partition happens. So network partition means like if I'm using FTT1 with RAID 1, 3 nodes, like one of the node go in isolation state. When I say isolation, it's not communicating over the vSAN network. Still, I am okay because what is my condition? If more than 50% watts are live, still my data is reachable. Okay, got it. But if any of the two go, what happens? VM will not continue to operate. Quorum is not available at all because now we are factoring like this is not available in the network. This is not, I mean, all the lost. Or now in this situation, this is something in some another space, some another space, some another space of network. So if we talk about RAID 6 FTT2, what happens? Host 5 and 6 have network partition. Host 5 and 6 have network partition. Am I okay? I mean, still my data is reachable? Answer is yes. Because again, more than 50%. What should be live? So out of 6, 2 gone away, but still my 4 nodes are okay. I am reachable. But if it will go like that way, 3, then the VMs which were hosting the data on FTT2 RAID 6 are unreachable. Maybe some of the VMs which were hosted data in FTT1 RAID 1, those are still okay. That is fine. But the VMs component which were following up the policy FTT2 RAID 6, those will gone away. This is the next situation. Okay, so any situation, we have to be careful like uh, what kind of FTT policy, how many nodes. So we have to design carefully. But the most important thing, we talked a lot about the component storage perspective, but in parallel, my compute and memory is also matters. Okay. So if you are planning something for FTT2 RAID 6, so it means that somewhere you are planning, I can sustain the 2 node failures. That's good. You have done on storage level. Okay. But what happened on HA level? Huh? HA admission control policy. So if this is FTT2 read 6, in HA admission control policy, I have set it 1. So maybe your VMs will get storage, they will not get the sufficient CPU and memory because you have configured an HA one host failure. So this should be in compliance. If we are planning something FTT2 read 6, in HA admission control policy, I have to assign 2 hosts to maintain the failure so that it should be aligned with your compute and memory storage also. Compute and memory space. Got it?
Yes, sir.
So simply meaning in HA admission control policy, we have to set like number of nodes to failure to tolerate at least 2 if you are planning somewhere FTT2 in any case. Okay, so there is a lab, access lab environment, create a storage policy, force provisioning. We will see that. vSAN object with reduced availability is something like that. If I am using 3 node FTT1 RAID 1, one of the node goes in maintenance mode or maybe away, then this situation is called reduced availability. Change the VM storage policy, verify the vSAN objects. Okay, so that's all we are going to play around in the lab session today itself.
Okay, sir.
Yeah, so Banu, if you are ready, it's your chance to, share the screen
Yes, sir. Yeah, I'll do that.
so that we can place around.
Sir, participant screen
Yeah,
sharing off.
I'm just enabling. One second. Let